Welcome everyone. I'm excited for our session today. This is first of what I hope to be an upcoming trend. Really just hang out with smart, accomplished folks and talk about interesting things. And I'm grateful for our first session to be a really strong one. For those who don't know me, my background's tech and cybersecurity, and I've helped build a few business-to-business software as a service companies across industries, all to successful transactions. And these industries include fintech, health tech, and insurtech. The health tech company, Cover My Meds, was a CBUS tech unicorn. Currently, I'm building my company Gamma Force, where we help tech and health tech companies with cybersecurity strategy. And we also help with execution, ongoing management of security programs, as well as cloud and security engineering. I'm super excited to be here today with Dan Manges. Dan's a friend and has a well-notched belt when it comes to tech companies in general, both as an entrepreneur and as a CTO. He cut his teeth as CTO building a fintech company, Braintree, which many of you have probably heard of. Braintree sold for $800 million in an acquisition. Later, as co-founder and CTO of Root Insurance, Root being another CBUS tech unicorn, they were valued at over $1 billion when they went public. Dan's latest company, RWX, they're helping with developer experience, particularly through their product Mint, where Mint is a CI/CD tool that's badass with concurrency and has more sophisticated failure scenarios. So when builds fail or tests fail, it doesn't take out your entire build process in a way that ruins your entire production platform. So today you could say you get to hang out with a couple unicorn catchers today. It's interesting. We fielded questions from the audience in advance, and I'm going to use that to ground a lot of our discussion today, Dan. And surprisingly, without prompting, it really favored cybersecurity. But I thought we'd talk a bit today, at least about scaling tech and scaling teams and scaling companies. And well, Braintree was nearly a unicorn, and Root certainly was. What do you think is unique about taking a company from zero to $1 billion based on your experience?
Yeah, thanks for having me in the fireside chat, Warner. I think the biggest challenge, and I alluded to this in my LinkedIn post where I shared that we were going to be doing this today, is really just moving super fast in the early stages of the company, especially when you're just starting out. You don't know if you're building the right product or you're building in the right way, if the product's going to get the traction that you need, or you're going to have to pivot. You're experimental, you're prototyping, you're really just trying to get some customer validation, get a little bit of traction, try to find something that can have a semblance of product market fit. And in that sense, you don't want to over-engineer things. You just want to learn as quickly as possible. But you also want to have a plan in mind for what's going to happen if things do go well. At both Braintree and Root, those companies grew really rapidly. I mean, Root especially. Like, we founded the company in 2015 and went public in 2020. So to go from zero to IPO in 5 years was just remarkably fast. And at the point at which I left in 2021, I believe we had about 250 people in engineering, which was a really large team to, again, come together like that quickly. So I'd say the biggest challenge to actually grow is just figuring out how to set yourself up to mature at the right pace, like commensurate with the stage that the company is at, without overdoing it in the early stages, but also without neglecting it too much, such that you don't have a solid foundation to build on once you go to hire more people and grow your team. And I think a lot of that applies to software architecture, but certainly also applies to cybersecurity.
Yeah, it's funny. I was thinking back to one of our early meetings at your office over on Gay Street, and that's when you're starting to build the engineering team more. And it's always interesting at that point, even in a company that's growing so fast, to go to IPO in 5 years. It doesn't feel like it at first, but it's so exponential when it really hits. And it reminded me of my early days at Cover My Meds. When I joined, it was about 20 or 30 folks, and folks were talking about how fast the company was growing. And I think we were over 100 before it felt fast to me. But I I remember anecdote we had. Uh, uh, we were hiring over 10 people every Monday. Over 10 people were starting near the peak of the growth. And it's just really crazy. I I I made some really strategic hires to get the foundation in place in the tech platform to enable that scale. And I do think that there are inflection points, particularly when it comes to technology and cybersecurity, but from a different angle, to get the right things in place early enough that it's not too complex, because retrofitting things like standardization, automation, and the way software is built, or the SDLC, once there's a lot of complexity there, it can be really difficult to retrofit. Um, but the biggest thing was getting the right folks on the rocket ship, so to speak, to co-op Sheryl Sandberg.
Yeah, no, I certainly agree with that. Like one thing I did in the early stages of building Root, which was extraordinarily difficult, was to hire engineers who had the capacity and experience of managing people, but were willing to join and basically take an IC role writing code. And this was really hard to do. It's already hard enough to find and hire talented engineers. Columbus is a decently sized market, but not huge. So to try to find people who were, had management experience, but yet hadn't been so far removed from writing code that they were too rusty, and to ask them to say, like, hey, I know you were the CTO of a previous startup, or you were a director of engineering over a couple of teams, but we have 7 engineers right now. I mostly just need people to write code, but I want to bring people in now who can learn the code base, learn the company, learn the domain, so that as we grow, I can grow a team underneath you. And I largely thought that would be effective just because I'd seen so many cases of organizations that would bring in leadership after the fact, where like the team would get really large. They didn't really have anybody that had management experience. Then you'd be trying to bring somebody in, but they wouldn't have any of the historical context on the organization. And there are managers who are capable of doing it and doing it extraordinarily well. And obviously, it does become important at a certain point to like bring people in at that level. But if you can kind of grow people from within and promote people into those positions as a company grows, I found that like it's a much more effective path. So that's kind of one example among many of moving fast in the really early stages of the company, but setting the company up for growth that worked well for us on the people front.
I like that a lot. And that's fairly unique. I've not heard anyone articulate an approach like that before. One of my pet peeves about tech companies is, and I like a lot of things about tech companies. I think you and I have chatted about this, Dan, where we have this predilection to promote our best engineers into management roles. They hit X amount of years at the company, or Y amount of years of experience, or they're too old to be on the keyboard, or look old enough to be a manager, whatever version of that anecdote you want. And I've seen folks forced into those roles, literally forced. And then usually over a couple years they cycle back into an IC role. And a different pattern that I've seen in big tech companies is, um, where they wouldn't hire people into senior manager, director, right? Director level roles. They'd want them to be an individual contributor first. And well, management's a completely different career path. We don't talk about it like that, but it's a completely different set of skills, and in effect, it's resetting one's career, and it's difficult and not the easiest job. So to put people into it who are highly skilled, and we need people who are skilled in those roles, as well as devalue those who have built the skills, wanting them to have top-notch engineering skills. Because if they still do as a director, they're probably not that great as a manager, because it's a lot of work developing those skills too. Like one part of that philosophy I do like. It took me a long time to get to this point, to have a version of that I think is true to the intent and less destructive in application. And that's having people, especially in middle management, engineering manager roles, definitely more team-facing management roles, having people who came from that professionally, people who had technical jobs and had some success at it, right? Not just because they're bad at it, they got promoted to manager. I see that too. That's ridiculous.
Sure.
Uh,
Yeah, yeah.
how do you balance that one, Dan?
Yeah, I think probably a little bit unorthodox on this front because I do think some of it depends on the organization itself and the processes and expectations of management within the organization. Um, but when you think about it like from the ground up, I've always viewed a manager's responsibility as effectively managing the output of their entire teams. You know, they're responsible for the combined set of deliverables that that the people reporting to them are responsible for executing on. Um, and when you start there at the bottom and you think about like that first level of management, you think about a technical profession like engineering, you know, if you're the person responsible for, let's say, like 6 engineers in the work that they're doing, you know, I personally think you do need to be pretty technical because I think you need to be able to deliver really great feedback to them to understand the contributions that people on your team are making and understand those from your own observations, not just from peer reviews. Um, you know, be able to understand how that engineer is approaching the problems that they're being tasked with, understand like who on your team to task with which problem. Like delegation has to be one of the top responsibilities of management. And
Mm.
I think if you're tasking engineers with doing work and you don't have a great pulse on like what's going to be required to do that work and how that aligns with that engineer's skill set, I don't know how you could possibly effectively delegate like to your team. So I think at least at that very first level of management, people actually do need to be pretty technical, but it depends on the organization. Like everything I just described are the expectations that I would have for first level engineering managers. There are organizations where HR is driving a lot of this process, and there's a lot of expectations around facilitating HR processes. You know, there's heavy expectations around facilitating just performance review process and like job leveling and, you know, everything that goes into just kind of the broader corporations management practices. And probably the more of that creeps in, you know, the more you do need to figure out like what the right balance of skill set is. And some organizations even do delineate between like tech leads and engineering managers because they have so much process from the organizational expectations that they need somebody to just solely execute that. And then they need a separate tech lead to do everything I was just describing of like, you know, how do you effectively utilize people towards like this set of goals? But obviously, as you start working your way up the organization, you know, it becomes a little bit different. When you're talking about a manager of managers, you're now talking about, okay, how does this person who has, you know, many managers reporting to them that each have many teams like effectively operate? But clearly the things they need to be observing, coaching, the things they need to be able to discern about somebody's performance are quite a bit different when you're at second level management on up. So this is another like really big shift as we're talking, Warner, about scaling tech companies, is going from a layer of management to like multiple layers of management, because I found at each layer the skill set that you need to have starts shifting pretty dramatically. But one thing I do want to call out before I pass it back to you is I really like the point that you made around, the promotion process and like the people that you have and whether or not you put them on a management track. Because I do think one good trend in the tech industry has been, fairly high level and highly compensated IC type roles. Because I think there are people that aren't interested in those responsibilities, but are just technically brilliant. And I think you want to feel like they have, you want those people to feel like they have a path for promotion and growth within the organization that's something other than management, because otherwise, they're likely to move and go on. I do think they have to have some people skills. Like, if you're going to be a staff level or principal level engineer in an organization, presumably you are doing technical work that you are going to have to in some way disseminate to, tens, hundreds of engineers within the organization. So you at least need to be able to like convey some of that knowledge. But I can certainly understand people not wanting to have direct people management responsibilities. And I do think it's critically important to, have a path for that talent.
Yeah, I couldn't agree more, Dan, when it comes to the dual path approach. And I think it was IBM that actually created that. Weird to attribute, but we're seeing that a lot more now too, because we shouldn't limit our best people's success simply because they're not managing people. I see a lot of organizations where managers will frequently make less than their best
Yeah.
engineering counterparts. I know I have
Yeah,
at
Sam.
different times.
At
Um,
least in
for
cash.
for those interested on or in the management path, there's a book called The Manager's Path. It's written by Camille Fournier. Really solid book. There are a ton of great management books out there, but that one in particular focuses more on what it means to be an engineering manager and a CTO in modern tech companies. Worth a read. And an interesting, I just attended Lead Dev in New York, a really great conference, tech company leaders coming together to talk about management. And in the part of the program that was focused on senior leaders, one of the presenters, Kevin Goldsmith, I believe, been a CTO of many large tech companies. I'm going to paraphrase it from memory, but the way he described the difference between engineering manager focused on team, director maybe focused on multiple teams, and then when you get to VP and start to look across the organization more and think about how you can collaborate and empower different parts of the organization that may or may not be the technology organization. And then CTO being primarily externally focused, thinking further ahead, strategy, product, market, customers, and how to position the company to be successful with that strategy, with technology. I found that to be a really pithy, simple, but on point explanation that I hadn't heard put quite that way before. Um, well, cool. I'm gonna pivot the conversation a bit, and talk more about cybersecurity, just so we can hit some of the topics that some of our attendees brought to the table. One of the topics that was brought was scaling cybersecurity at a startup with limited resources. I have my own thoughts, of course, more CISO hat, but I'm curious your thoughts, Dan.
Yeah, I'm probably more interested in yours. But it has been important for me in every role I've been in. Just because Braintree, we were handling credit card data. We had to offer PCI compliant services. We had to help our customers become PCI compliant. And, the most important thing for us was safeguarding that credit card information. And, similarly at Root, a little bit less scrutinous, excuse me, and insurance instead of payments, but we had a lot of personal information about people. And certainly once you get into the claims process, sometimes like medical records are even involved and, there's a lot to go through there. Um, But I've always thought that, it's important to figure out, and I hope you'll agree with this, Warner, the right security measures to put in place that still enable people to be able to get work done productively, and just being really thoughtful about like what that looks like. Um, for example, you could probably have the most secure network you possibly could by like air gapping computers. So you're working on workstations that like aren't even connected to the internet, but of course it'd be terrible if an engineer like, I don't know, had to go to a different workstation to like Google something. That's obviously like a ridiculous example, but there are these like security and productivity trade-offs that you have to be really mindful about. So, I think I've always just thought about this in terms of like, okay, what are industry best practices? What are secure defaults? Which frameworks and technologies are we using, and like how do we configure them appropriately? And then gradually just thinking about like what the right controls are to put in place with an eye towards the ones that, as you mentioned, I think at the beginning of our chat here, could be hard to layer in later. Because some of these, the cost of implementing it is kind of proportional to the amount of code or number of systems that you have and everything. And if you do it when you're small, you kind of pay this, little bit of cost as you go. But if you wait and do it when you're really big, sometimes it's really hard to go back through all the work that you've done with however many engineers over how many years and try to like, retrofit, some type of different process or way of doing things on top of that code base. So that's how I've thought about it, at a very high and general level, but I don't have near the wealth of expertise that you have on this front, Warner.
Yeah, I love those thoughts. I think in modern companies, we have a unique competitive advantage to build exceptional security capabilities with relatively low effort. And for a startup, it really depends on the company and the stage, right? I always ground in the business. And if it's truly early stage, say concept, pre-revenue, um, and they're trying to find product market fit, and well, say it's health tech, well, don't get PHI, don't get health
Yeah,
information until you need it, from a business perspective,
pretty
and then
hard
you
for
can
somebody to
delay HIPAA.
steal. Certainly, pretty hard for somebody to steal data that you don't have, right?
Exactly, and regulators can't fine you for data you don't have either.
Yep.
And if it's a company that doesn't have that business driver, don't do it at all, right? If you're a concept company and the difference is between implementing some security tool that costs tens of thousands of dollars or not doing it and the company going out of business, well, how much money is in the bank? And in that example, less than $50,000, right? So the risk is proportional there. Um, and then it's really about right sizing the activities with the business drivers and the risk. Health tech, you have to do it pretty early on,
Yeah.
but maybe you don't need PHI right away. Or when you do need it, they're making sure that you become HIPAA compliant, but not adding capabilities that slow your organization down or add unnecessary expense. So it's definitely a balancing act. I think all companies should do the basic stuff, right? Use encryption, use password. I call them databases, but password managers. Use some version of multi-factor
Yeah.
authentication. I do that personally. I tell my family members to do that when they ask about security. We should certainly do it in our companies, right? Easier to do stuff like that than it's ever been.
Yep. Yeah, for sure. I think some of my favorite tools are the ones where, I guess partly I think about this in terms of like what sort of tools exist that make certain things just impossible. Like I'm actually kind of like, if you don't have the data, you can't lose it or it can't be stolen. It just totally makes that impossible. But some of the other ones like, for example, like back in the day, you used to have like SSH keys that would, allow somebody to connect into a server. It's like, well, that SSH key can be stolen, but if you use like the secure enclave feature on Mac OS, I assume there's similar ones on Linux, like, your key is put into like this hardware thing that literally cannot be extracted. Now, once you put your SSH key in this thing where it can be used but can't be extracted, you just entirely eliminate this entire attack vector of like somebody being able to steal those keys. I think similarly, like one of the things we do with Mint, our CI platform at RWX, is we support OIDC authentication. So, it used to be that you would have these tokens, these deployment keys that would, be able to use to access certain environments or deploy new releases. And obviously, safeguarding these keys is of paramount importance because if somebody gets one, they could get into your production environment or maybe modify your production environment. But with OIDC, what you do instead is you just configure this protocol and this handshake between these two systems where you can say, okay, if this build is running on Mint on the main code branch, which is, presumably has branch protection rules in place and everything, generate an ephemeral short-lived token that this branch can use to deploy into the production environment. Well, now you have these short-lived keys. They can't really be lost. They can't be stolen. But you still have a way to authenticate like the deployment that's happening to make sure that only deployments running on your main branch can actually, push out new code to production. And I absolutely love techniques like that. And thankfully, engineers, I think, over time are getting better at developing things like this. But, there's still a lot of work to do on that front.
Yeah, I love that. Make it easy to do the right thing. So somebody asked about zero trust and DLP. And it's funny because zero trust is effectively my default mode for security programs. And it turned into this big marketing thing. But a simple way to put it is once upon a time in technology, we had trust by default in certain environments. So like the office network, trusting that network simply by act of being there. Well, the premise of zero trust is no default trust, right? And in cloud native companies, we have our infrastructure and infrastructure as a service platforms or some as a service counterpart, depending on our architecture and go to market and so on. And while the stuff we want to protect the most is protected really well there, and when it comes to workstations as attack vectors, I just mostly don't worry about it because of the way we're accessing the data or the network for the things we want to protect the most is either through the applications we build, web apps commonly, or we have engineers using more sophisticated protocols to access it with numerous controls in place, be it IPsec, MFA, or limited access to hosts based on ID. There are all sorts of things there, but mostly it's just workstations aren't a huge concern. And there's no big flat network to have ransomware stomp on the operations of the company either. And it's just a different paradigm. So when it comes to data loss prevention or DLP, it's just one of those things I don't even care about. And mind you, the tool isn't very effective. Like the best tools have
Yeah.
taken a ton of work to run and cost a ton of money. So even the best tools aren't really a great solution. It's a band-aid for things that are insecure, that are difficult to change. Very large enterprises, traditional industry, lots of history. And empathy to them, those are difficult problems, and that's why we have band-aid solutions. But zero trust is built into how we do things. And we've been talking a lot about the past, and I can't help myself, Dan, especially when you and I get talking, it's like scaling big companies. Well, you're building a new company now, RWX, relatively young. I'm sure in the past 3 years, you have some new lessons in scaling. I know it doesn't matter how many years experience I have. I'm always learning something new about business, technology, or security. Any highlights you'd share?
I think the OIDC protocol that I just described is certainly one, in this space of, coming up with these mechanisms where you don't need to have keys at all. You just entirely eliminate them, is a really great one. There's a lot that we're doing. So Mint, our platform, I think everybody on this call is, at least probably most people are pretty technical, but CI/CD platform stands for continuous integration and continuous deployment. It's effectively a cloud computing platform that's responsible for running all of the automation on top of every engineer's code change. And that's really the continuous integration piece of it is, what are we going to automate on top of every code change? A lot of times it's automated tests, but it can be like other checks. It can be security scanners, things that are doing static analysis of the code, looking for potential vulnerabilities. And that's a continuous integration side. But the continuous deployment side is especially sensitive because that's the side of this that is pushing out code to production environments. And a lot of engineering teams automate that now. They automate it so that they're doing some sort of like continuous deployment or delivery where, code changes are getting merged in. It could still, maybe only be once a day, but, still an automation on top of it so that it's not an individual engineer like pushing something out from their laptop, but it's like this set of scripts and this platform that facilitates all of that. Well, to do that, you have to have keys and you have to have credentials. And we try to eliminate as many of those as we can, but we also have to store some. And we've taken a lot of care to organize those into vaults. The vault concept is, I think, a pretty great model for security, where interestingly, all those secrets that we store, are scoped under a vault. And then we can put permissions on that vault and control who can access it, how they can access it, when they can access it. And we can also put really great auditing around it. And I think that's like another really important security mechanism too. So we've been spending a lot of time in the course of building RWX, just thinking about these aspects, thinking about how to improve the experience, and just thinking about like what the right defaults and processes are to make organizations, kind of secure by default as much as you can. Like you were talking about earlier, Warner, with, we used to trust by default, like now we don't. Those are the good kind of changes to be making.
Yeah, Vault's a great approach. In security, there's not much I trust. Strong encryption, math supports it anyway.
Yeah.
AES 256, based on first principles in physics, is unlikely to be broken. Things change, we learn, maybe it's flawed, but it's pretty trustworthy as far as encryption goes. And then strong key management and approaches like Vault are essentially build that in, right? Because what it's doing is using key management as well as it's
Yeah.
encrypting and storing credentials or data in a process around it. I really like that approach for things I want to protect the most. Say a password manager. If I don't control the key, I don't want my passwords in somebody else's servers. So for
Oh, for
the
sure.
things we want to protect the most, I'm starting to see more tech companies take that approach.
Yeah, and I think, largely we're starting to move away from passwords. Like I think passkeys are super interesting. I mean, I think the state of authentication right now on the web is a disaster. Like every time you got to log into a service, like I don't know, there's emails with like codes or magic links or like MFA on your phone, and I don't know. I feel like it's kind of getting out of hand, but I do think the ideas of passkeys are pretty cool. It's this extra mechanism to say like, has this device accessed this service before? And it's kind of this extra layer that I think is really helpful. And it lets builders of platforms do things like, you could show users, hey, you are currently logged in on these devices. And I think, people responsible for building products should help their users have good security. Because I think, it's not okay to just say like, well, if you had a bad password, that's on you. I mean, in some ways, yes, you do have to, let people be responsible for those things, but I think you also need to help them, understand if their account is, potentially being used improperly. So I think the ability to say, oh, there's this passkey tied to this computer, this login session was authenticated using this passkey is really great. Similarly, I think like WebAuthn is a protocol that will like, scope MFA sessions to the domain name that you're on. Which back to the point I made earlier around like just how do you completely eliminate certain attack vectors from being possible? I would say this is what I put like 80% of my attention on at startups I was at, is just like, how do I just make this something I don't have to worry about at all? So like a lot of companies go through a lot of efforts to prevent phishing attempts. They do training of employees and fake emails and whatever. But like once you have like MFA in place, you can literally make it so that like the web key that you're putting in, like the thing that you held up earlier, Warner, like is tied to the domain name that you're on. So it's like you no longer have to trust the person to like look at the domain name and make sure it's actually the domain name and make sure it's not some spoofing phishing site. If you hit that little MFA thing and you're on the wrong domain, it'll produce the wrong key. So there's just like no way that somebody can that a user can like mess that up. And I love solutions like that.
Yeah, I agree that authentication is a mess. It's like we're in many of our organizations, we're still using these legacy password policies like 9 characters, alphanumeric,
Yeah,
mixed case.
rotation.
It's like NIST. This was a while ago now. Finally, I say finally, it was probably close to around a decade. NIST finally updated the password policy standards, where we recognize now that passphrases, at least NIST recognizes passphrases are stronger than 8 character alphanumeric. So,
Yep.
but all of that is rather archaic band-aid, right? I don't think we've solved authentication well, and I really do like the fact that we're attempting to do that better right now.
Yeah, no, me too. I think this is another one where, it's kind of interesting. Like password complexity used to be the solution to brute forcing. If you
Mm,
want to make sure that somebody can't, access your account by effectively just trying every possible password, it becomes really important to increase the complexity requirements of your password. So that was, sometimes I feel like we lose this context over time because that was the impetus for password complexity is preventing brute forcing. But
mm,
we have like other ways to prevent brute forcing now. I mean, one simple one is a hashing algorithm that you choose. People used to log in using like SHA-1 hashes of passwords because everybody knew like, you don't want the backend service to actually store the password. You want them to store this hash of a password that you can use to check to see if a password is correct. Well, people would use these hashing algorithms that were designed for speed. They were literally designed to be cryptographically secure, but also to execute as fast as possible, which meant if somebody wanted to try, a million passwords, it might only take a few seconds on their computer to run a million passwords through this hashing algorithm and check that the resulting hashes. But somebody along the way realized, like, hey, using really fast hashing algorithms is a really bad idea for storing passwords. So you can now use hashing algorithms like bcrypt. And bcrypt, you have a cost factor that applies, and bcrypt you can make intentionally slow. Instead of taking a millisecond or even less to calculate a hash of a password, you can increase a computational difficulty and make it take an entire second. And this is fine if somebody's logging in. You don't want the other hashing algorithms need to be fast because you might have this really large file that you want to really quickly verify the integrity of this file. And that was the purpose of that hashing algorithm. But when somebody's logging into a service, you don't need to let them try like a million hashes in a second. You can let them try like one per second. So you can just crank up the difficulty of your bcrypt hash, and then people can only try, it's going to take a second of CPU time for a password they attempt, which totally changes the game on brute forcing. And I think eases up some of these requirements like, okay, 3 special characters, or I just had a service I signed up for the other day that prevented me from having the same character twice in a row, which ironically reduced the entropy of the password, but also like my password manager just kept generating passwords that wouldn't work. And, it was very annoying. And I think a lot of consumers, feel that annoyance.
yeah, I go through that very regularly. Yeah, the I'm so nerdy. I ran Unix servers back before we hashed passwords. So I remember when I installed shadow passwords on Linux for the first time. So
Yep.
we've come a long way, that's for sure.
Yeah.
I
And I think it's good that these things evolved. We went from storing passwords to storing hashed passwords. And then there were things like rainbow table attacks. So we introduced salts. But then, we just got different hashing algorithms altogether, which, was the right place to be. But, sometimes it takes time for these solutions, I think, to be discovered, but then sometimes even longer for them to be adopted.
Yeah, rainbow tables and cloud computing, mainly access to significant compute, really just changes the dynamic with traditional passwords. And
Yep.
that's why things like multi-factor authentication become so important, not only because of phishing, but it makes a stolen password yet less useful.
Right. Yeah, absolutely. There's another example on this topic, Warner, that you might like from my Braintree days. I can't remember if you and I have talked about this one before, but so credit card numbers are actually pretty short, use 16-ish digits. Usually you're exposing the last four. I'm sure everybody here has seen the last four on a receipt. Sometimes even a couple digits at the beginning can be exposed. So when we were building Braintree's payment system, we kind of had this problem where we would never give credit card information back to our users or the API or anything. There was no way to get the credit card information out unless you were leaving us as a customer, and then we had a secure protocol for that or whatever. But otherwise, you couldn't get it out. But we need to let people see if two transactions are on the same card. Because sometimes they wanted that for like customer identification or tracking purposes or like fraud prevention purposes of like, oh, wait, the same card was used for something that ended up being fraudulent or whatever. Well, this is like one thing that hashes are typically used for. Like you don't, you don't want to store the secrets, but you want to store something that the secret can like turn into, that is cryptographically secure. Well, unfortunately, with credit cards, if you're exposing some of the digits, like the possible number of inputs is really small that you have this brute forcing problem that we were just talking about before. So it took us a while to try to figure out like what to do about that at Braintree. But basically the solution we came up with was to generate a nonce, which is like a one-time use unique string. So every time we saw a credit card number for the first time, we would just build a random identifier for that credit card number in our system. And then in our system, we had a way to look up those random identifiers by the actual credit card number. But that way, it wasn't this case of like, this value is derived from this other value. It was like these are completely random. There's no algorithm for it. And we just have a reference table in our database where we can look it up. And now we can give this completely random identifier to our users, and we know it's not reversible. I guess that's how I should have described this before, is like, this identifier that's not reversible in any way.
Because
And
you're
it ended up being,
correlating.
yeah,
It's not
exactly.
the
Yeah.
math.
Right. Yep. So it ended up being like a really good solution to that problem. And I think, same thing with like elliptic curve, like cryptography or whatever, like non-reversible stuff is also one of those like, just eliminate a complete attack vector from even being possible.
Yeah, I love that. And kind of like you were saying, never share it. Your application was incapable of it. So
Right. Yep.
it took it off the table. It reminded me back, I forget what DEF CON it was, DEF CON 9 or 13. Fedor, the guy, I'm pretty sure it was the guy who created Nmap. These are old memories. Anyway, that DEF CON MD5 being broken,
Yeah.
hash collisions were announced, and since then, SHA-1's been broken. We're at SHA-256 now, so hashing is the method we trust for one-way irreversible data, but it's been broken, and errors in the math, and we're humans that can have mistakes. So in that case, you can have really high confidence and just take that attack vector off the table. I love it.
Yeah, another one you asked about, like, things we've been interested in at RWX. But I think another big improvement in security is like row level security in databases now. It used to be really important that all queries were scoped, you'd have SQL injection, stuff like that, but you'd also really want to make sure that like, one customer could never access another customer's data. Well, it's just really hard if you put that responsibility on engineers. It just takes one engineer and one code function to forget to like scope something properly. And you run the risk of a security vulnerability that could leak data. Well, you can now configure databases with row level security that if you have this multi-tenant database, you put the tenant identifier on every single row, and then you configure the database system itself to say, hey, for this authentication session, automatically scope all of my queries to only this one tenant. Now, you probably still want to scope all of your individual queries that the engineers are putting in, but the great thing is if they forget, you're not going to be at risk of leaking any data. So I think row level security is another one of those ideas that I'm really excited about.
Oh, I love that. Yeah, that's really strong from a security perspective. It, stuff like that's just been really complicated, and some of our cloud platforms are making it easier. We're not having to build or implement it from scratch.
Yeah, for sure.
The And that's security through layers, right? So if the application has a bug, well, the database has additional controls. And if we wanted to take it even a step further, we'd have encryption and key management tied to that same row level security. So additional controls there, which add complexity and overhead. There are plenty of solutions out there that reduce some of the engineering time, but it from a it takes a lot for me to recommend that approach. If someone really wants to do it, I'm never going to tell them no because it's a great security approach, but adding cost, complexity, and overhead, it's like in the credit card or PCI world, that type of encryption is non-negotiable for credit cards, but a lot of us, thanks to payments companies like Braintree, just don't deal directly with credit cards anymore, so we don't have to worry about things like that. And then in health tech, well, it's interesting because the use case for health information is part of the business processes. We have to use that data to do what we need to do, be it providing healthcare or providing services in the industry to improve on healthcare. So if we obfuscate it that much or make it more difficult to access the data through encryption, it's usually adding complexity on the end user side too. So if it's not visible, they can't use it and the business process is broken. So it's rare for me to have the luxury that I'd have in the payments industry and the healthcare industry
Yeah.
when it comes to data protection.
Yeah, no, that makes sense. I mean, definitely in that domain, part of the point is you're storing information that other people do need to look at, which makes it way harder,
Yeah, humans count.
right?
It's interesting. Anecdote that folks might not know. A role in security, the profession, is the most important thing to protect is people, their lives, right? And in tech, we often move past that super quickly because fortunately for a lot of the things we're doing, lives aren't at risk. That changes quickly in some situations, but I guarantee if you asked a room full of experienced security professionals, you get a fairly consistent answer with that one. Well, I'm going to wind us down. I want to leave a little more room for questions. I will touch on SOC 2 compliance briefly. This overlaps with a couple questions that were brought up by our audience. One was around tracking new changes for compliance, particularly in smaller companies or more modern companies, and then SOC 2 compliance. So I think there are two angles for tracking, right? On the SOC 2 side, I think a higher level, more control tracking. On the tracking changes for compliance, I might think tracking software changes or technology changes. So how about you hit it from the tech side real quick, Dan, and then I'll touch SOC 2 briefly.
Yeah, and we've gone through SOC 2 compliance at RWX, given the importance of what I discussed earlier. Change tracking obviously is important. We, especially being in like a heavy engineering company, push as much of it into code repositories as we can because we're just used to that mechanism. We're used to all those track changes being authenticated, tracked, approved. We use code-based collaboration tools for that. And for cases where we didn't have that, we actually just tend to use Slack channels. And we just have processes by which, one person needs to post and then somebody else needs to respond to that and approve it. And we make it super easy. We actually do this for pull requests too. An engineer, we have a channel. An engineer will just say like, hey, I'm ready to merge this. And another engineer will review it. But we have two different processes. One for like, I want a review of this code because like I want somebody to look for bugs and things like that. Like I want peer review of it. Another one for like, this is ready to merge, but like, please make sure that there aren't, any security concerns. Don't let me merge it unilaterally. So we call it our merge queue. We just post in that channel. somebody hops in there, they drop in an approval, and we just do it that way for like everything. So like access requests or changes, things like that. People just drop in Slack, somebody drops in to approve, and it's a really easy to administer process.
Yeah, I love that. And really the best way I know, if we're implementing not only in our deployment automation, our change automation, and just have our process naturally create the documentation, and then doing things like chat ops for things that involve humans to collaborate. It doesn't get better than that. When I spoke at DevOps Days Amsterdam many years ago, that's when we were first talking about DevSecOps, and um, uh, there were people who would advocate that having manual code or manual deployment approval and all I'm not even remembering the term. Release managers, like people who had a job to do all this manual stuff for the once a month or 6 month release, right? That is less secure and less effective for tracking technology changes for audits. So,
Yeah, no,
um,
I totally agree, Warner, because usually those people don't have context. If they're just the handoff point and they don't really understand what's being handed to them, then they're more likely, I think this is what you're indicating, they're more likely to just blindly follow something that they shouldn't be following.
and if the only way to make change is through that automation process, well, more secure.
Right. Yep, for sure.
Well, on SOC 2, biggest thing I'll leave folks with is if you're a young company or even a scaling company, are your customers asking for it consistently? Will you not be able to get business without SOC 2? If not, you can probably hold up for a little bit. And you might want to implement the beginnings of a security program, be more risk-based as opposed to having to meet SOC 2 requirements. And then if the business driver raises its head eventually from your customers, well, then you do it. And second big point I'd make is you don't have to do a bunch of default controls, right? A lot of tools and a lot of professionals say you have to do this control. SOC 2's requirements. You can customize the controls to meet the requirements. So do it in a way that is best aligned to your organization and culture. Well, this has been super fun, Dan. Any closing thoughts about you, your company, or anything more you'd like to share?
No, I think thanks for having me on, Warner. Yeah, it's really great to talk through this with you, and I think these are really important topics. Yeah, nothing else
Oh,
to add.
if folks want to reach out to you, what's your preferred way?
Oh, email's great, dan@rwx.com.
All right, cool. And I'm on LinkedIn. Appreciate you all. We'll be doing this again at some point in the future. Enjoy the rest of your day. Take care.